Hello dear student friends, this is second video in test of significance. I welcome you all to this video. I am Dr. Mohammed Shafee. Today we will discuss about this Chi-Square test. So it is one of the test of significance. It is a Chi-Square, not Chi-Square. So this Chi has come from the Greek word Chi. So this test is called as Chi-Square test. It is very simple, very easy to apply and very easy to interpret tests. So let us see about the Chi-Square test. So it offers an alternate method of testing the significance of difference between two proportions. So proportions we calculate in case of qualitative data. So when you want to compare the characteristics of the two samples in terms of proportions, we use Chi-Square test. So it has the advantage that it can also be used when more than two groups are to be compared. So even if two groups or more than two groups also can be compared with the help of Chi-Square test. This test is applied for qualitative data and also alternative to the test of significance between two proportions. And Chi-Square test is a type of non-parametric test, and it is not based on any assumption or distribution of any variable. So normal distribution is not required in case of Chi-Square test. Now let us consider this example of two vaccines. So there is a trial of two whooping cough vaccines. So here they have given there are two groups in which group vaccine A and vaccine B is given, and in the A group 22 people are attacked and 68 are not attacked. So it is 90 total. The group which received vaccine A, and attack rate is 24.4%. There is another group which received vaccine B. Attacked number of people are 14, not attacked are 72, total are 86, and the percentage of attack rate is 16.2%. So just by seeing these two figures or two percentages of attack rate, we can say that the attack rate is more in group A vaccine and attack rate is less in group B vaccine. So it means that B vaccine is more protective to the whooping cough compared to the vaccine A. But is it true statistically? So we apply Chi-Square test to compare whether there is a significant difference between these two attack rates or it is same. So in this case, we find that vaccine B looks superior to vaccine A. Now let us test it by applying a Chi-Square test. So whether this difference is because of chance or there is any, whether really the B vaccine is superior to the A vaccine. So that will be tested with the help of Chi-Square. So first step in application of any test of significance is state the null hypothesis. So first we set up a hypothesis called null hypothesis, which says that there is no difference between the effect of the two vaccines. Null hypothesis says that vaccine A and vaccine B are similar in the effectiveness. Then we proceed to test the hypothesis in quantitative terms, which is done by these steps. So we first pull the results from the two vaccines. We calculate the proportion of people attacked in vaccine A, that is 0.204. Then proportion of people not attacked is 0.795. So from these proportions, we now calculate the expected number of attacks or cases and those not attacked. So in each group, we have to calculate observed numbers are given. We need to find out the expected number of attacks in each cell. So now we have to apply 90 by 0.204. So it comes to 18.36. So this is the expected number of people who are attacked in group A vaccine. The expected number not attacked is 71.55. So which is actually 90. Then similarly, expected number of attacks by vaccine B will be 86 into 0.24 is equal to 17.554, and not attacked will be 86 into 0.75, 68.2. So what we have done here, observed numbers are given. We have find out the expected number in each cell. So now we shall write this table again with the observed and the expected numbers. So here the formula is given to calculate particularly for 2 by 2 table, like in terms of ABCD. So formula without age correction is Chi-Square is equal to AD minus BC whole square into N divided by A plus B into C plus D plus A plus C plus B plus D. Formula with age correction is AD minus BC minus n by 2 whole square into n divided by a plus b into c plus d plus into a plus c into b plus d. So this is the formula which is used for 2 by 2 table or contingency table. So here we have rewritten the table. So observed values are 22, expected is 18, in non-attacked observed is 68, expected is 71. In B group observed is 14, expected is 17, and not attacked observed is 72 and expected is 68. So here in the differences are given. Now applying the chi-square test. So chi-square test is calculated by summation of O minus E square, that is observed value minus expected value of square divided by the expected value. So here we have found in this table observed and expected for each observation. So we have to calculate chi-square for each observation. We have to put up the values, like for this observation, it will be 22 minus 18.36 is whole square divided by 18.36. For this observation, it will be actually here it is 68 minus 71.35, so it comes to 3.55. So the difference is already given here. So 3.55 square divided by 71.55, that is the expected. Plus for this, the difference is minus 3.54 square divided by the expected 17.54. And for this also, we have to put up the values like 3.60 square divided by 68.37. So each of these formula will give one chi-square. So we go on and like this chi-square for this is 0.72, chi-square for this is 0.17, chi-square for this is 0.171, plus chi-square for this is 0.19. So we add up or we do the summation of all these chi-squares and we get the whole chi-square. So this is the chi-square value for whole table. So the value is 1.79. Now we need to find out the degree of freedom. So degree of freedom is found with the help of number of columns and number of rows in the table. So how many columns are there? 2. How many rows are there? 2. So the formula for calculating degree of freedom is equal to column minus 1 into row minus 1. So it will be 2 minus 1, 2 minus 1. We have to put up the value. So this degree of freedom is calculated for 2 by 2 contingency table or any number of columns and rows. We can calculate the degree of freedom by the formula column minus 1 into row minus 1. So here the columns are 2, rows are 2, so it comes to 1. So 1 into 1 is equal to 1. So degree of freedom is 1, chi-square value is 1.79. So before we proceed, what are the uses of the chi-square test? So it is used for test of proportion, it's also used for test of association, and also used for test of for goodness of fit. So here again, the steps are described. So first we need to find out, state the null hypothesis, then make the contingency table, find out the observed values are given, and we have to calculate the expected value. So for calculation of expected value, in general, the formula used is column total into row total divided by sum total. So suppose if you are taking for vaccine A attacked, so that column total you have to take, that row total you have to take, multiply and divided by sum total, means total of all the 4 values. Then we calculate the chi-square value of each cell by using the formula. So chi-square formula remains same, observed minus expected square divided by the expected. So then we have to sum up all the chi-square values and we get the overall one chi-square value and then calculate the degree of freedom, which I already told you. Now after getting the chi-square value, we need to find out the corresponding p-value from the chi-square table. So we refer to the chi-square table with 1 degree of freedom. So the value of chi-square for probability of 0.05 is 84. So to get the significant value of p less than 0.05, required chi-square value is 3.84 at degree of freedom 1. I will show you this in the table. So observed value, that calculated chi-square value is 1.7 and it is much lower than the 3.84. That's why there is no significant difference between the vaccine A and B. So the null hypothesis is true and we accept that thus there is no significant difference between vaccine A and B, or you can say that the B vaccine is not superior to the vaccine A. So the test is valid only if the expected number in each cell is not less than 2. So observed values should be more than 2 or more than 5. Otherwise, we need to apply the Fisher exact test. So this is the chi-square value table. So degree of freedom for our observation is 1, and the p-value, this is the significant level of p. So to get the significant difference, we should at least get 3.841 value of the chi-square. If the chi-square value is less than this, there is no significant difference. If the chi-square calculated chi-square is more than 3.84 from the table, then it is significant. So p-value will be less than 0.05. As the value of chi-square increases, the p-value decreases. So there is a strong association, or B vaccine will be more superior than the A vaccine. So the value of P as is reduces, the significance level increases. So like this, we need to apply the chi-square test and find out the chi-square value, compare the calculated value with the table value, and then we have to interpret the results. So if the calculated value of chi-square is more than the chi-square value given in the table, then there is a significant difference between the two factors. So the p-value will be less than 0.05. It means that the observed difference is significant. So here you can say if the chi-square value comes more than 3.854, then the B vaccine will be superior to A vaccine. If the p-value is less than 0.0, so it is highly significant. There is a more strong difference. And if the p-value is more than 0.05, it is not significant. So in our case, the p-value is more than 0.05 because the chi-square value is calculated chi-square value is less than the table chi-square value. So p-value will be p more than 0.05, and it is not significant. It means that B vaccine is not superior to A vaccine. Now coming to the eighth correction, that is the reduction of the absolute difference between observed and expected by 0.5 is applied to. When it is applied, when there is a four-fold table, means degree of freedom is 1, there are 2 columns and 2 rows. That is called as four-fold table, or it is also called as 2 by 2 table or contingency table. In other table where degree of freedom is more than 1, but when any of the E value is less than 5, then the eighth correction is applied. In cases where n is less than 50, chi-square values near significant value levels should be interpreted with caution. So we need to see the number of cases in the. Now this is another example of the table where you can apply the chi-square test, but here you can see there are 5 rows and there are 4 columns. So this is on a positive number, positive, positive male, negative, positive female. So there are 4 columns and 5 rows. So here the degree of freedom will be 4 columns minus 1 is equal, that will be 3, and 5 rows minus 1 will be 4. 4 into 3. So here it will be 12 degrees of freedom. So we have to calculate for each these values. These are the observed values. We have to calculate the expected value. You have to write here in the bracket. Then you have to write for the female also, male also, and then you have to apply the chi-square, calculate the chi-square value with the help of observed and expected value, and sum all the chi-square values, and then at particular level of degree of freedom, read the chi-square table and find out the table chi-square value, and then compare. If the calculated value is more than the table value, then it is significant. P value will be less than 0.05. So like this, we interpret the chi-square. It is very simple, very easy test to perform and apply and interpret also. Now this is another example which is mostly given in your practical exam, where this shows that there is a effect of smoking on development of cardiovascular diseases. So smoking done, not done, and how many number of people develop the cardiovascular disease. So here they have given that chi-square value is 8.89. Degrees of freedom will be how much it will be? It will be 1 for this table because it is contingency table 2 by 2 table. The p-value is less than 0.05. What question is asked? State the null and alternate hypothesis. So what will be the null hypothesis in this case? There is no association between smoking on development of cardiovascular disease. Alternate hypothesis will be there is an effect of smoking on development of cardiovascular disease. Now the p-value is less than 0.05. It means that we have to reject the null hypothesis and accept the alternate hypothesis. So what alternate hypothesis says? It says that there is the effect of smoking on development of cardiovascular disease. So depending on this p-value, you have to interpret the result. So here you need to only state null hypothesis, state alternate hypothesis, and interpret the results in terms of chi-square value and p-value. So like this is a very simple example for 2 marks. It is given in the practical examination. So thank you very much.